All right, guys, we got some something I want to go over that we did not quite get to. And if you jump to page 20 in the book, you'll see it. So every now and then, I do this on my test. Every now and then, you're going to get a problem that'll have either a 1+i or a 1-i in it. And it'll be raised to some big power. A power a lot bigger than you actually want to mess with. I mean, it could be something like 1+i to the 6th, which feasibly you could deal with without too much trouble if you actually started multiplying it out. But a lot of times it'll be 1+i to the 12th or the 21st or the 25th, okay? So let me just show you, if you see this at a math tournament, a lot of time what the people at the math tournament are wanting you to do is use something called de Moivre's theorem. And de Moivre's theorem is the way to take an imaginary number, rewrite it in what they call trig form, and then apply this little theorem, which is about raising imaginary numbers to powers, which works great when you have ugly imaginaries. But when you have really nice, pretty imaginaries like 1+i or 1-i, it's not your best way to go. So here's what I would encourage you to do. You will see this on your test. I hope that you don't make it hard. Just know that if you were needing to raise something to the 12th power, let's say, isn't something to the 12th a bunch of squares? Like, couldn't you think about that as 1+i squared a whole bunch of times? So just think about 1+i squared and 1-i squared. Like, so first of all, look at 1+i squared. If I literally were to square 1+i, what do I get? What's our rule? Square the first. That times 2. And then square the last, right? But what does I squared equal? Wouldn't you add that -1 to that +1 and they would cancel? So all you have left here is 2i, right? What if you had 1-i squared? Isn't that kind of the same thing, except you'd get a -2i in the middle, but you'd still get the 1 in the I squared part, which would still cancel. Are y'all with me? So technically, does that make sense? Everybody with me? I don't want to go past it. It's not.
Is it I squared -1?
Yes. So that -1 will add to this +1 and cancel. That makes sense? Because you're replacing this with a -1. This is already a +1. They're going to go away, leaving me just the 2i. And that happens there. Sorry, that's a -1. That's a +1. They cancel. Right? So hypothetically, if I now want you to go 1-i to the 6th, couldn't you think of this as a 1-i squared to the 3rd? Isn't that 1-i to the 6th? And you already know 1-i squared. What is 1-i squared? And you can memorize that or not. I mean, I have it memorized because I've done it so many years. If I did not, it's not worth that much. It didn't take me much time to figure that out, right? So this is essentially a -2i to the 3rd. And what is -2i to the 3rd? -2 cubed is -8. And what is I cubed? -i. So what do I end up with? 8i. And I didn't have to do de Moivre's theorem, which you'll learn maybe later. Let's try it again. 1+i to the 12th. You already know that 1+i squared is 2i. So couldn't I write this as 1+i squared how many times? 6? Isn't that the same thing as 12? And then couldn't you replace this 1+i squared part with a +2i this time? And if I replace the inside part with a 2i, I'm just doing 2i to the 6th. What's 2i to the 6th? 2 to the 6th, which we all know is 64. And then I to the 6th is the same thing as what? I squared. And then I squared is the same thing as a times a -1. So -64. And I didn't have to use the modular step. Now, those are really straightforward problems. And you might or might not see something like that. But what most of the time you see is junk like these examples 3 and 4. So let's talk about these. If you can do these, you're in pretty good shape. Now, there's one situation right here that you could make your life a little easier by doing, but a lot of people don't notice. So I'm going to talk about maybe not the most efficient way to do it, but the way most people do it. So most people, in light of what we just learned, how do you rewrite 1 plus I squared? Think about this, because remember, that's what I know. 1 plus I squared. What do I do to that to make it 21? I mean, the short answer is 10 and a half. But what are you going to do with 2i to the 10 and a half power? I don't have an answer for you. So that's a problem. Okay, now I'm not saying you can't do something with it eventually, but it might be tricky. So what if I did this? What if I get really close to 21 by raising it to the 10th? Now that would only get me how many of those? 20. That means there's an extra 1 plus I left over. Now, is this now 21 1 plus i's? Okay, great. Let's just go. What could I do on the bottom? Pretty much the same thing, right? So I could treat that like a 1 minus I squared to the 10th with an extra 1 minus I left over. And then if anybody sees a shortcut after we're done with this, I want you to show me. And I can think of one, but I want to see if y'all can think of it. Now, what did we say 1 plus I squared was? Okay, so I'm going to replace this with a 2i, right? There. So I get 2i, bring down the 10, bring down the 1 plus I. And then what can I replace that with? A negative 2i, bring down the 10, bring down the 1 minus I. Now look at that and tell me, what could you do?
Could you cancel the 2i?
Why? Because they're different right now.
Because when you to the 10,
Yeah, that 10 is going to make it positive, right? So if that 10 is going to make that positive, now these things perfectly match. I can get rid of all that. And all I have left now is 1 plus I over 1 minus I. And what do I do with that to clean it up? How do I rationalize that? Multiply by the conjugate. So I'm going to multiply the top and the bottom by the conjugate of the bottom, which is the same thing as the bottom, but just change the middle sign. I'm going to FOIL out the top, which watch me do that slowly. 1 plus I plus I plus I squared. Or if you see that it's a binomial, you can just say what? What's 1 plus I squared? You already know that, right? It's 2i, but you're going to get that anyway when you cancel this negative 1 and this positive 1. Now, the bottom we have not talked about. What's 1 plus I, 1 minus I? Do I have to FOIL that? Because the OI part of the FOIL always cancels, doesn't it, unconjugates. So really all I got to do is go first times first. Last times that's negative I squared. What does an I squared mean? So if I'm going 1 minus a negative 1, that's really 1 plus 1. So all of that's 1 plus 1 are a 2. And I left with just an I when all is said and done. Now here's the shortcut if you happen to see, and I would especially maybe try the shortcut. Because these two things are raised to the same power, couldn't I think of this like this? Right? Since it's the same power? So let's ignore the whole problem for a second, and let me just look at just this inside part. So if I have 1 plus I times a 1 minus I, you just said you would multiply by a conjugate. And when I'm foiling all that out, I end up getting a 2i. When I FOIL all that, I end up getting a 2, and the 2's cancel. So that inside part's equal to I. So I can replace the inside part with the I. What's I to the 21st the same as? I to the what? Why I to the first? Because if I divide 4 into 21, it has a remainder of 1. So I divide 4 into that, get a remainder of 1, rewrite it as an I. That's a lot simpler, I think, than the other. But I wanted to show you that process, because if you ever have an odd power, like if I said, hey, what's 1 plus I to the 8 to the 19th? If I ever give you something, or even like this one, we're forced to do it, you're going to have to think about how to raise it to something to get close to 25, and then just tack on an additional one. But if it's even, you don't have to worry about that. All right, so let's check out number 4, and then we'll go to what we're doing today, which it's one of the more fun things I think we do. You might not think it's fun, but I kind of like it. Mainly because I can remember like 28 years ago figuring out how to do these, and I was so proud of myself. And then I had this student come up and go, you know, there's a lot easier way to do it. But I don't feel bad because this guy was like wicked smart. Google and Microsoft got in a bidding war over him. Did I tell you about this? Like he went to Rice. He literally in the early 2000s, he knew more about computers than anybody Homewood City schools had on their staff. So whenever they had an issue, they would call him out of class and he would go fix stuff. He was 17. Like it was amazing. So he went to Rice to study under this woman who was like an eminent scholar in computer technology. So he went there just for her so he could be under her tutelage for 4 years. And I kid you not, like literally, can you imagine being so good at what you do that 2 companies get in a bidding war over you out of college? Like you're interviewing and you're not answering the question, well, why should we hire you, young man or woman? He's literally sitting in a room going, what's your next offer? And the 2 companies are Google and Microsoft. I mean, it isn't like Publix and Piggly Wiggly. I mean, massive companies. I think this was 2004 when he graduated. I think his starting salary was $130 something a year plus a free apartment. And you know where Google is? He ended up working at Google. Like a free apartment in the San Francisco Bay Area is not the same as a free apartment in Birmingham. I mean, it's like, I got a friend who leases a place out there. He runs a hedge fund. His rent this was 4 or 5 years ago, was $9,000 a month. His rent. He paid $500 a month for a parking space. It's insane out there. Anyway, whatever. So this one right here, don't feel bad for him. He's managing a $5 billion hedge fund, of which he pulls 2% a year off of. He and 4 other guys. He's printing money. Anyway, Vestavia grad, local grad. Right here, 1 minus I to the 25th. Went to Auburn University. Where are you? Well, and then Stanford Business School. So 1 minus I to the 25th. Do you have a way to rewrite that? Can't wait to show Pozo that chart on the songwriters. It's so great. Anyway, 1 minus I to the 25th. How would you rewrite it?
1 minus I to the 24. I mean 2 to the 12.
Okay, so 1 minus I squared to the 12th gets me to 24 with an extra 1 minus I left over. So that's 25 1 minus I's, 4096 on the top. All right, what's 1 minus I squared? Negative 2I. So if I replace the 1 minus I squared part with a negative 2I, I get negative 2I to the 12th times a 1 minus I to the first. And what does the 12 do? Well, first of all, the 12 makes the negative what? Positive. And then you end up with what? That is 2 to the 12th, I to the 12th. And the 2 to the 12th cancels because you know that 4096 is 2 to the 12th. But you still have I to the 12th on the bottom. Oh, but wait, what's I to the 12th? It's 1 because it's a bunch of what? I to the 4th. If it goes in there evenly, it has no I's left. They all cancel out, right? So that's gone. And all I have left is 1 over 1 minus I. So how do I take care of 1 over 1 minus I? And what did we say 1 minus I times 1 plus I is? 2. And do I ever leave a fraction that has an I in it in that form? No, we put it in what? A plus BI form. So I got to put all the 2 under each part so that I have nothing but the real part, not plus or minus, just plus. And then nothing but the imaginary part. You can write 1/2 I or I over 2. You with me? So just be aware of those. Don't make them hard. Remember, just think in terms of what's squared. And if you forget what the squared is, then just just write it out twice, FOIL it out. All right, so here's what I want to talk about today. All right. Infinite roots and fractions. Okay, so long time ago, I was teaching people how to do these, and that student, the guy Evan Roseman, who worked out at Google, or may still, I don't know, I can't find him anywhere on the internet. I've looked for him. He's kind of a recluse, very funny and outgoing in here, but then didn't talk to many other people, except his physics teacher and me and maybe Homer's, because we were like math and physicsy, or the computer guy who taught how to do computers. So here's what I was showing them. So I showed them the problem with okay. So this is an infinite fraction. This is an infinite root on number 2. That means they go forever. So when they go forever, how do you even get started? Like, for instance, if I had given you this, if you didn't have that plus ... on there, you could do this, right? You could take 5 and add it to 2/5. You'd find a common denominator. You get, 25 over 5 plus 2 over 5. You'd have 27/5. And then you could take the 2 and divide it by 27/5 by multiplying by reciprocal, and you get 10/27, whatever. And then you could add 5 to that and get that answer, and then divide that by 2. And you'd finally get there. The problem is I had to start here. How do I start there when it never ends? It's going forever. So what I taught them to do was, well, I want to find out what this value is, and I don't currently know what it is. So I'm going to name it. So I'm going to literally create an equation and call this x. You can call it any variable you like if you have a favorite variable, but I'm going to call it x. And then what I'm going to do is I'm going to start operating on it algebraically. What I'm going to start doing is I'm going to start taking stuff away from this fraction. But I'm going to peel off a couple layers. Now, because it's infinite and it repeats, after peeling off a couple layers, it's going to look the same as it did when I started. Like right now, it looks like 5 plus 2 over 5 plus 2 over 5 plus 2 over. I'm going to peel off that 5, that 2, and get it to where I see 5 plus 2 over 5 plus 2 over 5 plus 2 over. But after doing that, it's not going to be equal to x anymore. It's going to be equal to something else. But if the first part's equal to x, and then the next part that's the same as the first part is equal to something new, I can put the new equal to the x. You'll see this in a second. But I'm going to show you a better way to do this. So if you just want to kind of watch this, this is what my original couple classes had to do. So the first thing to do to start getting this, peeling off one of the layers, essentially, is to get rid of that 5. And that 5 is gone. And actually, I want you to see that 5, so I'm going to leave it right there. So that part is gone. And now I have 2 over this. Well, 2 over this, I don't really like the times 2 on the top. So I'm going to multiply this fraction by 1/2 on both sides. And that's going to cancel that 2. Now I'm going to write out what I have here. Does everybody see that this is what I currently have? Everybody see that? So I've subtracted 5 and multiplied by 1/2, and now I have a 1 left because when I cancel that, there's still a 1, but all this other junk. Now, would you consider this on the left a fraction? It's not a fraction plus something, right? It's just a fraction, top, bottom. The bottom's ugly, but it is a fraction. Can't I, if I have an equation, flip both sides? So if I flip both sides, now this 1 will be on the bottom. So if the 1's on the bottom, I really don't need it. So all I have right now is this. And I got to flip that side too, right? Do y'all see this? I could write it like that, but it's not really necessary because dividing by 1 doesn't do anything. Oh. Can I go back? Oh, nice. I'm not going to risk anything else here. So I really don't need that. Now I have a question for you. Isn't what you see right here in red the same as what you saw right here in black? Think about it. Read it in your head. 5 plus 2 over 5 plus 2 over 5 plus 2 over. What do you have here? 5 plus 2 over 5 plus 2 over. That's the same thing, right? And what is this equal to? This was originally equal to what? Before you moved the 5 over, we named it x, but now it's 2 over x minus 5. Well, if that's x, and this is 2 over x minus 5, and they're the same thing, then couldn't I say that x equals, that x equals 2 over x minus 5, and take that original thing and set it equal to that thing. And now I don't have an infinite equation anymore. Now I can cross multiply or multiply both sides by x minus 5. I can move that 2 over. And you're going to see the vast majority of these are not going to factor. So you're going to have to remember the quadratic formula. I know you all know the song. You do not have to sing it. But one thing I would caution you on, I see people, they do this a lot and write 2a there. It's the whole thing. So with that in mind, x is the opposite of the b value, plus or minus the b squared, 25, minus 4 times the a times the c, a negative 2, all of that over a 2 times the a. And that leaves me 5 plus or minus the square root of 33 over 2. Now, here's what you have to think a little bit. Clearly, this original problem can't be equal to 2 things because you're only doing one thing, right? So which one is it? Is it the plus or the minus? So here's what you need to do to be able to think through this. And I use the word, I'm going to use the little expression ish a lot. Somebody give me a ballpark on what they think root 33 is equal to. It's not 6 because that's root 36, and it's not 5 because that's root 25. So it's what? Between the 5 and the 6. So let's go with 5-ish. Okay, so what would happen if I took 5 and added 5-ish to it? 10-ish? What's 10-ish divided by 2? 5-ish. So one answer is about 5. Don't do this in college. They'll mock you. Okay, but it's great here. What about 5 minus 5-ish? That would be what? Like a negative-ish, right? A negative point something-ish divided by 2. Again, negative point something-ish, even smaller. What makes sense if I'm beginning with 5 and I'm adding something to it that I know is positive because there's not a single negative sign up here? Wouldn't it make sense that this is 5 plus something? There's no way it could be negative 0-ish, is there? Only one of these answers are going to make sense. So I go with the 5-ish, which was what I did when I went with just the plus sign. Now, this is the way I used to teach it, which required a lot of algebra. And then along came Evan Roseman and went, Mr. Harris, it's very excessive. He said, what if we just did this? He said, go ahead and name it. But if possible, can you see in this where the problem starts to repeat itself again? Now, again, be careful in what you circle because every year people say they know, but they're not circling the right stuff. And I always go and circle it so you can kind of look at it, especially if you're struggling with this. This problem started out with a whole number 5 plus the fraction 2 over, right? Where do you see the whole number 5 plus 2 over happen next? Do you see it right there? 5 plus 2 over, and right there, 5 plus 2. Now it also is there, but I want to circle as much of this as I can. So did y'all see that? Wouldn't you argue that what I circled is the same as the original? Now I have people that look at this and go, no, because there's 1 less 5 and there's 1 less 2, or whatever. There's no such thing as, well, yes, I realize this is infinite, so there's an infinite number of 5s, but this has 1 less than infinite number of 5s. Infinity is infinity, right? I mean, tell me, if I told this story, stop me. When I was a kid, I vividly remember sitting in this tree out in front of our house. It was like a crabapple tree, and the cicadas would land on it and drop their shells. And I don't know, we were like 3rd grade. We used to like trying to gather up those little creepy shells. You know what I'm talking about? Anyway, so we're sitting up in the tree taking a break, and this conversation started. Tell me if you've had this, because I thought this was unique to me, but turns out like 40% of my students have had this same bizarre conversation with their friends. And it started like, hey man, how old's your dad? And somebody would say, I don't know, like 38. And then the other guy would come back with, my dad's 45. And then the first guy would say, well, I was just kidding. My dad's really not 38. He's 50. And then the other guy would go, I was kidding too, man. My dad's 77. And it would go back and forth. Who's had this conversation?
Well, not like exactly that, but like something similar to that. Like always trying to one up them.
Yeah, but it wasn't age. Anybody have it with age? Nobody had it with age in this class. Oh, you did? Okay. Normally it's like 10 people. But anyway, it always ends at some point with well, my dad's infinity. But I remember in my conversation, it finished with, I don't know if I said it or he said it, I remember, but my dad's infinity plus 1. But anyway, infinity plus 1 is still infinity, right? So even though you might look at this and go, but that's less 5s, how can it be the same? It is the same because it goes forever, right? And I know some people do not like that idea of infinity. You do not like the idea. How about this? 0.9 repeating is equal to 1. You like that? Some people do not like that. It's true, though. Even super easy to prove, right? Is it? So it's not hard to prove. It's even easier to prove with the little geometric sequences. But some people, not some of y'all are staring at, what? But my point is, infinity is hard to wrap your brain around sometimes, concepts like that, because we don't deal in an infinite world. We don't. I mean, we can say things like, the grains of sand on the seashore are infinite. But no, if you have enough free time, you can freeze time and start counting. I mean, if you had a long enough night, you could get through them. Got last green. I got it. But we just die before that. So our time is so finite on this earth or whatever. But point is, don't let infinity bother you. Trust it. If this is x and what I circled is the same thing as the original, then that is also x. So I can bring down the 5, the plus, the 2, and whatever I circled, replace it with an x. And even though that looked different than my other equation, the instant you come in here and algebra this thing to get rid of your fraction, now it looks the same or awfully close. I mean, granted, when you set it equal to 0, then it looks just the same. And you're going to get the same 5 plus root 33 over 2. So I'm a big fan of what Evan Roseman did back in the day. Makes it a lot easier on the algebra. I mean, a lot easier. Okay? So let me show you a couple of examples of this same thing, whether it's a fraction or whether it's a radical. Check out this one down here. I'm trying to figure out what root 6, whole thing radical, plus another root 6 with a radical, plus another root 6 forever and ever and ever is equal to. I have no idea. I don't even know where to get started. So what do? I go, well, let me just name it. If I name it x, can I look at this infinite problem and circle the part that repeats? Now, what would you say this thing started with? A radical, then a 6, then a plus, right? So go to the next radical, don't circle too much, 6 plus. Now, if this original thing is x, and if what you circled is the same as the original, then what you circled is also what? X. So drop down the root, drop down the 6, drop down the plus, replace it with an X, drop down the equal, drop down the X. And now the infinite part is gone like it was before. You can start the algebra. And what did you learn to do here? Square both sides gets me this, which in this rare case, when you subtract everything over, this actually factors. That is pretty rare. And if you want to use quadratic formula every time, you can. But isn't it pretty obvious that this thing can't equal -2? First of all, square roots can't be negative. But second of all, there's not even a negative in this problem, right? So there's no way it could be the -2. So I go with the 3. Now let me show you where it gets trickier. All right. If you don't think, if you're in good shape now, you'll be all right on this, but you're going to have to write in the next couple minutes, pick an option. I'm jumping to number 6. Now, what's annoying looking about number 6? The 8. The 8 clearly is disrupting your infinite process. Now, I'm going to show you or tell you what I think is the most logical way to deal with this. The most logical way, though, sadly, probably 70 to 80% of the people that choose this logical way forget sometime between when they started and finished that they chose this method. And they forget to fix it at the end. That's getting slashed. And here's what they do. They basically go, well, the 8's bothering me. It's messing up my infinity, so I'm going to ignore it completely for now, do this, and then when I'm done, add 8 back to it. Great plan. What you would do if you took this right here and solved for x, you would go through the process and you would end up getting -3 plus root 21 over 2. That's what you'd end up getting for x. Except your x was not the original problem, was it? Your x is just that part. So what would you then need to do to it? Add 8. Here are the 2 things I see people do wrong. This is the first one. Oh, add 8 to it. Ouch. I'd probably only dot you for that, but you didn't add 8, right? You added 8 to the numerator. What you really added was what? 4, because you added 8 over 2. What you really needed to do was add that to it. And if I added that to it, that would get me the 13 that I was really supposed to have. Literally, the people that do it this way, probably 70% of them forget to go back and add 8. And then maybe a couple of them add 8 the wrong way. But the vast majority of those people, even though this seems like the most logical way to deal with it, end up missing this problem. So here's what I do. I try to create a system where the most people can do the same problem the same way over and over. So either do it that way and don't forget and know who you are. If you're like, yeah, I'm pretty forgetful. And that might not be your best option, but it is an option. Here's the other way. The other way is just still call it x like you did before. All right? But subtract the 8 to the other side. Now, keep in mind what I'm doing. I'm calling this whole thing x, not just this part. So in the end, I'm going to end up with x equals. That's going to be my answer for the whole thing because I named the whole thing x. But here's what I do. Or here's another option. Subtract that 8 from both sides. So now, and keep getting rid of junk until it looks the same. Does it, I'm sorry, or until you see a nice consistent pattern. Do you see a nice consistent pattern now? Do you see a nice repeating situation? But guess what? This repeating situation is not equal to x. It's equal to what now? X minus 8. So when you go to circle where it repeats, be really careful where you circle. Is this the repeated part? Can y'all see that it's not? Because this original problem, this problem right here is 3 on the top over. So that's not the repeated part. This is the repeated part, isn't it? Y'all seeing that? But this is not equal to x. This in the blue here is equal to x minus 8. So that means what I circled is equal to what? X minus 8. So I have to come in here, drop the 3, drop that 3 in the plus, drop that x minus 8, but I need to replace that circle part with x minus 8 because that's what the blue part was equal to this time. And that people mess up too. I mean, a lot of people do it this way, replace that with a single x, but it wasn't equal to x now. It was equal to x minus 8. Now you got to clean that up a little bit. So 3 over an x minus 5. And if it were me, cross multiply, which is the same thing as multiplying both sides by an x minus 5 because they cancel. And I get x squared minus 13x plus 40. And when I move everything over, I get that, which is not very lovely. And you're going to have to just suck it up and go x equals negative the b. That squared is 169 minus 4 times the a times the c over twice the a. That ends up being 148. Actually, that wasn't that bad. 169 minus 148 is 21. And then let's think, is it plus or is it minus? Now, according to the key, it's plus, right? Let's think about it. What's root 21 ballpark? 4-ish. What's 13 plus 4-ish? 17-ish. What's 17-ish divided by 2? Not quite 9, right? So 8-ish. So one option, the positive option, would give me 8-ish. What's 13 minus 4-ish? Minus 4 would be 9. So what's minus 4-ish? 8-ish, because it's a little bit more, right? 8-ish divided by 2? 4-ish, so the minus would be 4-ish. Look back at the original problem. I'm starting with 8. Can 8 plus something that's clearly positive, because it's not a negative in the problem, can 8 plus something possibly be 4? So, and for the record, if in doubt, go with plus, because 9 out of 10 of them are positive of the choice. So if in doubt, go with plus. Like if it's ciphering and you're up there and time is running out, just go with plus. But if you look at the original problem and it's riddled with negatives, be careful. Maybe take the time to check. Y'all seeing this? This is the strategy that I find people have more success with because they don't have to remember to go back and do something at the end. And listen, this is a journey. There's a lot of math. It's so easy to get done at the end and go, oh, great. You circle it and you forget, oh, yeah, I forgot about that original number. I didn't have to worry about it here because it was already built into the problem when you made that substitution. All right, there's another one. How much time? 10. There's a good one. Oh, yeah, right. That's not it. Ah, here it is. Number 10. Anyway, whatever. Number 10, at first glance, really looks like it has a nice pattern, doesn't it? But does it? 5 minus 1 root, 5 minus 2 root, 5 minus 2 root, 5 minus 2 root, 5 minus 2 root. What's out of place? The 5, and then even the minus 1 right there, it should be a minus 2. So it's the 5 and the minus that are in the wrong spot, aren't they? So I need to get rid of them. Now, what you could do is completely ignore. You could look at this and go, all right, forget the 5 and the minus. I'm going to figure this out. I'm going to figure it out. And then when I'm done, I'm going to go 5 minus whatever I got. You can do that. And when you plug it in there and go 5 minus that, you're going to end up getting 6 minus root 6. I guess your answer was this. You would have gotten that. And then you would have gone, nope, you would have gotten that. And then you would have gotten, oh yeah, 6 minus, no, you wouldn't have. You would have gotten something like, who knows what you would have gotten. But you'd have gotten something, and you would have had to go back and do 5 minus. but the vast majority of people forget that or mess that up. So consistently, you could say, name it, and let's get rid of the 5 and the minus. So how do I get rid of the 5? Subtract the 5. Gone. How do I get rid of the minus? Multiply both sides by a negative. And now take a look at your answer. And if you need to rewrite it to see it, do you see a nice consistent pattern? Square root of 5 minus 2, square root of 5 minus 2, square root of 5. Nice and consistent. Except now, what is this thing equal to? Negative x plus 5. So when you go to circle, whatever it is that repeated, you're not going to replace it with x. You're going to replace it with negative x plus 5. So where do you circle? Is it this? Nope, because this didn't start out with a 2. It's not that. Is it this? A lot of people do that. No, because this didn't start out with a 5 minus a 2. It started out with a root 5 minus. Is it this? Yes. Now let me show you the next error. People go, okay, replace that with the negative x plus 5, and this is what they write. What did I do wrong? Looks really good, but what did I do wrong? I'm going to need to distribute that 2, but I'm going to need this to be multiplied. Y'all see that? This is 5 minus 2 times that. And all the other ones, it was plus that we've done. But this is 5 minus 2 times that. Make sure you're careful. If that's 2 times, it's got to be 2 times there. Because you're literally bringing everything down. Bringing down that radical, bringing down the 5, bringing down the negative, bringing down the 2, bringing down the minus, the times, replacing that with that negative x plus 5, bringing down the equal to negative x and 5. Cleaning this up, 5 plus 2x minus 10. And at this point, square both sides. You can clean it up a little bit more and square both sides. Gives you 2x minus 5. Binomial squared. Last little bit. Subtract the 2x, add the 5. And even though that looks like it factors, it doesn't. It's a 30. So here we go. X equals negative the b. B squared is 144 minus 4 times the a times the c is a 30. And even as big as those numbers are, 2 times the a, it really isn't as bad as it looks. What is 144 minus 120? 24. What's root 24? 2 root 6. And can I cancel like this? Why not? It would have to be, the 2 would have to be a factor of the top, the entire top, right? So I could factor a 2 out of there and then cancel it. Or I can cancel that 2 with 1, 2 in each part. That works also, but make sure you don't cancel that first way. It's got to come out of both parts. I do not have to put it in a plus bi form. By the way, that's plus or minus. But how do I know to go with plus and not the minus? Actually, how do I know to go with minus and not the plus? Think about it. What is 6? What's root 6 ballpark mean? 2-ish? What's 6 plus 2-ish? 8-ish? Is there any way 5, that was a minus, I can subtract something from 5 and get 8? Well, I could if it was negative. I could subtract the negative and get 8, but square roots are positive. So I can't subtract a positive number and get an 8. So there's no way the plus would work. What's 6 minus 2-ish? Well, 3-ish, right? Because you're subtracting 2 and then some. So a little bit more than 2, which puts you 3-ish. totally 5 minus something could be 3. So it must be the minus. So don't always think that it's always positive. But notice that there's a lot of negatives in this problem to begin with, wasn't there? So if you look up at the original problem and you don't see any negatives, it's going to be the positive version. And if there's some negatives, it still could be the positive version. But it's possible that it's negative, the negative version. Y'all with me? So your homework is just to work with these and to get confident with them. And all the answers are there. The keys, the solutions are on Schoology if you want to see the process. But again, depending on your method, if you do the method where you wait till the end to add, I didn't do it that way, your final answers will match, but your X's values will not match. They'll be different, possibly. All right. What page is it? 286? Yeah, that's the first one for this 9 weeks.
I would have come. Oh, I see.